Right now, in this very second, you're convinced of a lie. You feel motionless, perhaps leaning back in a chair or holding a phone, surrounded by walls that feel anchored and a floor that feels absolute. But this stillness is a masterful biological illusion, a trick of your nervous system designed to keep you from losing your mind to the staggering reality of your own velocity. In truth, you're currently outrunning the speed of sound just by existing, being carried eastward at over 1,000 miles an hour on a sphere of rock and iron that never pauses to breathe. But here is the thing that should genuinely bother you, the mystery that haunts every equation in modern physics. If you were to add up every spinning galaxy, every orbiting planet, and every rotating black hole in the entire observable cosmos, the total rotation of the universe appears to be exactly zero. Every individual piece is screaming in motion, yet the whole is perfectly silent, suggesting a universe that keeps perfect books on a quantity whose origin it completely refuses to explain. We are told that spin is inherited, passed down from the birth of stars to the rotation of atoms, but that leaves a massive hole in our story. If the universe is a closed system where motion can neither be created nor destroyed, then where did the very first deposit of spin come from? Today we aren't just looking at the mechanics of why things turn, we are looking for the missing ledger of creation, the first deposit paradox. Welcome to the start of a journey into the most fundamental rhythm of existence, a choreography that began before time had a name. To understand why your world refuses to stay still, we have to look past the simple beauty of a spinning top and into the cold, hard mathematics of the universe's accounting system. Every documentary you have ever watched on this subject likely told you the same comfortable story, that things spin because they formed from something else that was already spinning. They tell you that our Earth rotates because it inherited its motion from a collapsing cloud of gas and dust 4.5 billion years ago. They explain that galaxies swirl because they were nudged by their neighbours in the early crowded darkness of the newborn cosmos. This is the narrative of inheritance, a cosmic chain letter where motion is simply passed from one hand to the next. But this explanation is a sleight of hand that avoids the most uncomfortable question in physics. If the law of conservation of angular momentum is as sacred and absolute as we believe, it means that spin is a finite currency that can only be redistributed, never generated from nothing. This is the accounting mystery. If the universe is a perfect bookkeeper that never lets a single unit of rotation drift out of order, how did the account get its opening balance? Imagine the universe in its first few milliseconds, a raw and violent sea of energy bursting outward in an event we call inflation. During this era, the fabric of space itself expanded by an incomprehensible factor, stretching any pre-existing motion so thin that it should have vanished into effectively zero. If the early universe had a net spin, inflation would have diluted it until the rotation was so slow that it would take billions of years just to complete a single degree of a turn. Yet when we look out today, we see a universe that is restlessly, almost frantically, rotating at every scale. We see stars like Vega spinning so fast they're flattened into glowing ovals, and neutron stars rotating hundreds of times per second, faster than a kitchen blender. This is the paradox of the first deposit, the realization that we are living in a high-stakes economy of motion without any record of the initial investment. Current science tries to answer this through a concept known as tidal torque theory. The idea is that in the early universe, matter wasn't perfectly smooth. It was filled with tiny, random quantum hiccups and density fluctuations. As these overdense regions began to collapse under the patient pull of gravity, they didn't fall straight inward. Instead, they were tugged and twisted by the gravitational influence of neighbouring clumps of matter. One galaxy would pull on its neighbour, providing a torque, a twisting force that set the neighbour spinning in one direction, while the galaxy itself was forced to spin in the opposite direction to compensate. It is a system of mutual exchange, where rotation is not created but borrowed from the gravitational potential of the void. This explains why, when you add up the billions of galaxies spinning clockwise and the billions spinning counterclockwise, the total sum is zero. The universe is a master of balance, ensuring that every local plus in the rotation column is matched by a minus somewhere else in the cosmic ledger. But even this explanation only moves the goalposts. It assumes that there were density fluctuations and gravitational tugs to begin with. It assumes a universe that was already messy enough to allow for these interactions. Yet the most profound and obscure theories in the law vault suggest that this mechanical view of spin might be completely backwards. We are taught to think of space as a stage, a pre-existing container in which objects are placed and then set in motion. But what if spin isn't something that happens in space? What if spin is what creates space? This is the realm of spin networks and loop quantum gravity, a radical inversion of reality where the geometry of the room you're sitting in is not a static background, but an emergent property of trillions of discrete quantum spin values. In this view, the universe doesn't spin because of an ancient collision or a gravitational nudge. It spins because rotation is the raw material from which the fabric of space-time is woven. As we begin this exploration, we have to confront the possibility that stillness is not just a biological illusion, but a physical impossibility. The first deposit was never a single event, but a fundamental requirement of existence itself. We see this in the quantum world, where particles like electrons possess an intrinsic spin that they never acquired and can never lose. They don't spin because they were pushed. They spin because not spinning is mathematically forbidden by the very laws that allow them to be matter. This intrinsic, built-in rotation is the anchor of the material world, the force that keeps atoms from collapsing and allows chemistry to build the complex molecules that eventually became you. Every breath you take is powered by a rotation that has no cause, only a presence. If the competitors' transcripts ignore the accounting mystery, it is because it is a frighteningly deep hole to fall into. It suggests a universe that is not just a machine, but an elaborate bookkeeping exercise where every orbit of a planet and every twist of a galaxy is a line item in a balance sheet that was signed at the moment of the Big Bang. The rotation you feel, or rather, that you're forced to ignore, is a legacy of that first transaction. We are all participants in a cosmic dance that is perfectly balanced, yet perpetually moving, living inside a system that keeps perfect books on a mystery it has no intention of solving. You aren't just sitting in a room, you are riding a local fluctuation in a zero-sum game of infinite rotation. And to understand why that dance never stops, we have to look closer at the first chapter of our cosmic history, the law that makes every turn inevitable. This brings us to the core of the first deposit paradox, the realization that while we can track the flow of rotation with pinpoint accuracy, we are essentially looking at a river without a source. In every other area of science, we look for a cause, a prime mover. But here, the laws of physics, specifically Noeth's theorem, tell us that the symmetry of space demands that angular momentum be conserved. It says that once the books were opened, the total could never change. This means that the spin of the galaxy you see through a telescope tonight is exactly the same spin that was present in the diffuse hydrogen clouds 10 billion years ago, just concentrated and refined. Every turn of our Earth is a fossil, a literal piece of the Big Bang that you can feel in the rhythm of the tides and the cycles of your own sleep. We are not separate from the first motion of the universe. We are the current expression of it. But if the total rotation is zero, then the first deposit wasn't a gift of motion, but a split. The universe didn't start spinning, it started twisting. It broke its own symmetry to create the structures we see today, trading a perfect, motionless void for a dynamic, rotating reality where everything moves so that nothing has to truly change. This is the high retention hook that keeps the cosmos together. The tension between the urge to collapse and the refusal to be still. Without that first deposit of spin, gravity would have won the war in the first few seconds, pulling all matter back into a single, featureless point of darkness. Rotation is the only reason we have a stage to stand on, the only reason the accounting mystery has anyone around to investigate its missing ledger. We are living in the dividends of an ancient, unaccounted for investment of motion, and as we will see, the universe is very strict about collecting its debts. If you could peel back the skin of reality, past the atoms, past the light, and past the very concept of empty space, you wouldn't find a void. You would find a calculation. Right now, as you listen to these words, you are being carried on a sphere of rock and iron spinning at 1,000 miles an hour. But you feel nothing. You experience a stillness that is, in every physical sense, a total fabrication. For decades we've been told the same story, that we spin because of gravity, because of ancient gas clouds, and because of the sacred laws of angular momentum. But these explanations only tell us how we spin, not why the universe seems so obsessed with the turn. What if the rotation of every galaxy and every subatomic particle isn't just an accident of physics, but a computational shortcut? What if we live in a universe where constant rotation is simply the most efficient way to manage data, matter, and entropy in a grand simulated engine? Today, we're going to look at the simulation shortcut, the meta hook that your favorite space documentaries completely ignored, and uncover the evidence that we are living inside a reality that refuses to be still because stillness is too expensive to render. Welcome to a journey into the architectural secrets of the cosmos. To understand why everything in the universe spins, we first have to admit that our current textbooks have a massive accounting problem. They talk about the conservation of angular momentum as if it's a simple rule of the road. They tell you that once something starts spinning, it is remarkably stubborn about stopping because there is no friction in the vacuum of space to steal that energy away. But here is the massive law gap. Conservation only explains the redistribution of motion, not its origin. If the universe is a closed system that keeps perfect books, a ledger where every rotation must be accounted for, then where did the very first deposit of spin come from? Physics can explain how a cloud of gas collapses and speeds up like a figure skater pulling in her arms, but it cannot find the first deposit slip for the initial motion. This is where the simulation shortcut theory begins to feel less like science fiction and more like a necessary explanation. In the world of computer science, when you're building a massive, complex environment, you don't want to calculate every single linear path for every single object for all of eternity. That requires infinite memory and infinite processing power. Instead, you use loops. You create systems that repeat, that cycle, and that stay localized. Rotation is the ultimate cosmic loop. By setting everything in the universe to spin, the engine of reality can maintain the stability of matter without having to constantly calculate new linear coordinates for every particle moving toward an infinite horizon. Think about the way a planet orbits a star. If that planet were moving in a straight line, it would eventually leave the local rendering area. The system would have to keep tracking it across ever-expanding distances, adding more and more data to the ledger. But by using gravity to curve that motion into a circle, the planet stays in one place relative to the Sun. It becomes a localized, stable asset in the cosmic simulation. Rotation isn't just motion. It's a way to keep matter contained, organized, and, most importantly, computationally cheap. The same logic applies to the smallest scales imaginable. Inside every atom in your body, electrons possess an intrinsic spin, a built-in angular momentum that never stops and never requires energy to maintain. It isn't a motion they do, it is a property of what they are. From a computational perspective, this intrinsic spin is a hard-coded value, a fundamental bit of data that allows the simulation to distinguish one particle from another without having to track their individual histories across time. This brings us to one of the most staggering statistics in all of science, the net zero paradox. If you add up the angular momentum of every spinning galaxy, every orbiting star, and every rotating black hole in the entire observable universe, the total sum appears to be exactly zero. Every piece of the cosmos is restlessly, almost frantically, turning, yet the whole is perfectly still. In any other context, this would be an impossible coincidence. It would be like a trillion tops all spinning in different directions on a table, and yet somehow the table itself never moves a millimeter. But in a simulated universe, this makes perfect sense. It's called perfect bookkeeping. The simulation ensures that the total spin budget of reality remains zero so that the system as a whole never drifts. Every plus in the rotation column is perfectly balanced by a minus somewhere else, ensuring that the grand architecture of space remains stable and fixed even as its contents are in constant motion. But why use spin to manage entropy? Why not just have a static universe? The answer lies in the cosmic heartbeat of rotation. In our universe, entropy is the slow march toward disorder, the cooling of stars, and the spreading of heat. But rotation provides a way to delay that decay. Spinning systems like galaxies and solar systems create a dynamic equilibrium, a balance between the inward pull of gravity and the outward push of centrifugal force. This balance creates structure where there should only be chaos. Without spin, every cloud of gas would collapse straight down into a featureless sphere, or worse, a single, dense point of darkness. There would be no disks, no spiral arms, and no stable platforms for life to emerge. Rotation is the mechanism that allows the simulation to build complexity out of simplicity. It turns a uniform fog of hydrogen into the intricate, nested structures of the cosmic web. There is a deeper, more obscure theory buried in the law vault of modern physics, known as loop quantum gravity. This theory suggests that space itself isn't a smooth, empty stage. Instead, space is constructed from a discrete network of spin values, often called a spin network. In this view, the very geometry of the room you're sitting in, the distances, the volumes, and the angles, is an emergent approximation of trillions of tiny quantized rotations happening at the Planck scale. Space isn't where spin happens. Spin is what space is made of. If this is true, then the reason everything in the universe spins is that rotation is the raw material of the hardware itself. We are not just passengers on a spinning planet. We are the conscious expressions of a reality that is fundamentally built from the logic of the turn. If you look at the fastest dancers in the cosmos, the spinning black holes, you see the ultimate expression of this computational efficiency. Near a black hole, space and time are dragged along with the spin, a phenomenon called frame dragging. The rotation is so intense that it actually warps the geometry of reality, turning space-time into a swirling vortex where light and time themselves begin to loop. Here the simulation reaches its limit. In these extreme environments, the shortcut of rotation becomes so powerful that it extracts energy from the void, powering the most luminous objects in the universe, the quasars. These are the overclocked engines of our reality, showing us what happens when the logic of the turn is pushed to its absolute maximum. We often think of stillness as the natural state of things, and motion as something that requires an explanation. But as we have seen in a universe governed by the laws of rotation, stillness is the only thing that is physically impossible. Every atom in your body, every drop of water in the ocean, and every star in the sky is participating in a shared, ancient choreography that may be the very thing keeping our reality from crashing. The simulation shortcut suggests that we are not here by accident, and our motion is not random. We are part of a system that turns because turning is the only way to exist. We are born from spin, sustained by spin, and as the universe continues to expand, we are being carried through a grand circular dance that began with a first deposit we still haven't found. The next time you sit in a quiet room and feel as though the world is at rest, remember the lie of stillness. Remember that you are outrunning the speed of sound, that your atoms are broadcasting their quantum signatures at 1.42 gigahertz, and that you are part of a zero-sum ledger that is perfectly balanced against the void. You aren't just an observer in the universe. You are the universe briefly aware of its own turning. And the reason everything spins might be the most meta secret of all. Because in the infinite calculation of existence, a loop is the only thing that can last forever. If you look at the floor beneath your feet, it feels solid, dependable, and most importantly, it feels still. We've been taught to think of space as a grand empty stage, a silent container where the stars and planets are placed like actors in a play. We imagine that this stage is passive and that rotation is just a type of motion that happens on it, like a dancer twirling across a floor. But what if the stage itself is a lie? What if the reason everything from the smallest electron to the largest galaxy refuses to stay still is that rotation isn't something matter does, but rather the very material that space is made of? Recent breakthroughs in a radical field called loop quantum gravity suggest that if you could zoom into the fabric of reality, past the atoms and past the light, you wouldn't find a smooth void. Instead, you would find a spin network, a discrete digital-like web of pure angular momentum where every inch of space is constructed from the logic of the turn. We are about to move beyond the traditional laws of motion and enter the geometric mystery, where we discover that we don't live in a universe that contains spin. We live in a universe that is spin. Welcome to the ultimate frontier of cosmic understanding. For as long as we have looked at the stars, we have been obsessed with why they move. Our current documentaries and textbooks offer a very satisfying mechanical explanation: the law of conservation of angular momentum. They tell us that when a massive cloud of gas collapses under its own gravity to form a star, it's like an ice skater pulling in her arms. Any tiny random drift is amplified into a frantic, high-speed rotation. This is a beautiful truth, but it's a truth that only describes the how. It treats space as if it were a pre-existing, empty bucket that was simply there before the first particle ever moved. This is what physicists call the background-dependent view. The idea that space is a stage and matter is the content. But a superior understanding of the cosmos requires us to pivot. We must ask, what if there is no bucket? What if the geometry of the room you're sitting in right now, the height of the ceiling, the width of the walls, the very distance between your eyes and this screen, is not a static background, but an emergent property of 1 billion trillion quantum spins? This is the core of the geometric mystery. To solve it, we have to travel down to the Planck scale, a realm so unimaginably small that the concept of smoothness completely breaks down. If you magnified an atom to the size of the entire observable universe, a Planck length would still be smaller than a single grain of dust. At this scale, modern physics tells us that space is quantized. It isn't a continuous sheet of fabric. It's more like a piece of chainmail made of discrete individual links. In the framework of loop quantum gravity, these links are called spin networks. Imagine a graph made of nodes and edges. The nodes aren't in space, they are the volume of space. The edges connecting them aren't lines through a void, they are the area of space. And here is the part that changes everything. The mathematical labels assigned to these links are not distances or weights, they are quantum spin values. This means that the very geometry of our reality is built out of angular momentum. When you measure the area of a surface, you're actually counting the spin of the edges that cross it. When you feel the volume of a three-dimensional object, you are sensing the collective spin of the nodes within it. Spin is the raw material. It is the fundamental algebraic currency from which the stage of the universe is woven. From this perspective, the reason everything in the universe spins is not because of an ancient gravitational nudge or a first deposit of motion. It's because everything is made of the same rotational fabric as the space it inhabits. This turns our intuition upside down. We usually think of a planet as a solid object that happens to be rotating. But in the geometric mystery, the planet and the space around it are both emergent approximations of an underlying network of spins. Rotation isn't a behavior, it's an essential feature written into the laws of reality from the very beginning. It's as if the universe is an ocean, and we have spent all of history studying the way the waves move without ever realizing that the water itself is made of nothing but microscopic whirlpools. This leads us to the provocative work of Roger Penrose and his twister theory. Penrose argued that we have been looking at the world from the wrong end of the telescope. We think points in space and time are the most basic things, and that motion is something added later. But in twistor theory, the spinning directed structures are primary, and the points in space-time are just secondary projections, shadows cast by a reality made of pure angular momentum. If Penrose is right, then stillness is a local illusion created by our coarse, macroscopic perspective. We see the smooth surface of a lake, but we miss the restless, rotating algebra that makes the water possible in the first place. This geometric perspective also solves the accounting mystery that haunts traditional physics. Traditional physics struggles to explain where the first deposit of spin came from if the universe is a closed system that keeps perfect books. But if space itself is constructed from spin, the ledger was never empty. The angular momentum was hard-coded into the hardware of the universe. The rotation of a galaxy is just a large-scale echo of the same quantum spin that defines the very pixels of space-time. Consider the fastest dancers in our cosmos, spinning black holes. When a black hole spins at nearly the speed of light, it doesn't just rotate like a ball, it drags the fabric of space and time along with it. This is called frame dragging, and it is the ultimate proof that space and spin are inseparable. Near the event horizon, the distinction between motion and geometry completely disappears. Space-time becomes a swirling vortex where light and time are forced to follow the spin. This happens not because the black hole is pushing the space, but because the black hole is so dense that it reveals the underlying rotational nature of the space itself. This brings us to a deep philosophical realization. If the geometry of space is built from spin, then we are not separate from the cosmic dance. We are participants in a shared, ancient rhythm. The intrinsic spin of the electrons in your body and the spin networks that form the floor beneath you are made of the same fundamental logic. Stillness is not the absence of motion, it is a state of synchronization with the underlying turn. We often crave stillness, thinking it represents peace. But in a universe built from spin networks, absolute stillness would mean the end of geometry itself. It would be the deletion of the links that hold space together. The reason everything spins is that the universe refuses to vanish. It keeps turning because rotation is the only way to maintain the ledger of existence. As we look out at the spiral arms of distant galaxies, we are no longer just seeing objects moving through a void. We are seeing the raw material of reality expressing its own structure. Every orbit, every revolution, and every quantum flip is a reminder that we do not live in a static container. We live in a dynamic, emergent process where the stage and the actors are one and the same, a grand interlocking system of rotations that has been turning since before time had a name. You aren't just standing in a room, You are an observer made of spin, standing on a world made of spin, in a universe where the very concept of place is just a beautiful, rotating approximation of the truth. You are lying to yourself right now, in this very second, as you sit in your chair, perhaps with a phone in your hand or a laptop on your desk. You are convinced of a profound physical lie. You feel motionless. You feel a sense of absolute grounded stillness. The walls of the room around you feel permanent and fixed. The floor beneath your feet feels like the very definition of an unmoving foundation. But this stillness is nothing more than a masterful biological illusion, a trick of your nervous system designed to keep you from losing your mind to the staggering reality of your own velocity. In truth, you are currently outrunning the speed of sound just by existing. At this exact moment, you're being carried eastward on a rotating sphere of rock and iron at a speed of 1,674 kilometers per hour. If you could somehow step outside the system and watch your still room from a distance, it would look like a high-velocity, choreographed rotation, so fast and so smooth that it defies human perception. But here is the thing that should genuinely bother you, the mystery that haunts every equation in modern physics. If you were to add up every spinning galaxy, every orbiting planet, and every rotating black hole in the entire observable cosmos, the total rotation of the universe appears to be exactly zero. Every individual piece is screaming in motion, yet the whole is perfectly silent. The universe keeps a perfect set of books on a quantity whose origin it completely refuses to explain. We are told that spin is inherited, passed down from the birth of stars to the rotation of atoms, but that leaves a massive hole in our story. If the universe is a closed system where motion can neither be created nor destroyed, then where did the very first deposit of spin come from? To begin solving this, we have to dismantle your sense of reality. We have to look at the floor beneath you not as a solid object, but as a platform hurtling through a void. The Earth doesn't just have a rotation, it is a marble spinning in the dark, and its rotation is the very engine that makes your life possible. Without this constant twirl, one side of our world would be an eternal furnace, while the other would freeze in a permanent shadow. The spin saves us by balancing the fire of the sun and the ice of the void. But the reason you don't feel it is a concept known as an inertial frame. Your body is not wired to detect constant motion. It is wired only to detect changes in motion. Because the Earth, the atmosphere, and the oceans are all locked in a synchronized dance, moving together in a perfect invisible reference frame, your brain files this 1,674 kilometer per hour journey away as stillness. But let's scale up, because the 1,674 kilometers per hour of the Earth's rotation is practically a crawl compared to what comes next. While you're spinning on the Earth's axis, you're also falling around the Sun at a staggering 30 kilometers per second. That's about 67,000 miles per hour. You're currently on a journey where you're falling toward a massive ball of nuclear fire, but you're moving sideways so fast that you keep missing it. This is the miracle of an orbit, a continuous fall that never lands. If we slowed down even a fraction, we would spiral into the sun and be incinerated. If we sped up, we would be flung into the frozen dark of interstellar space. We exist in a perfect, high-speed balance between falling and escaping. And yet, even the sun isn't a fixed point. Our entire solar system is hurtling around the center of the Milky Way at nearly 500,000 miles per hour, specifically about 230 kilometers per second. We are passengers on a galactic journey that takes 230 million years just to complete a single lap. In the entire history of our species, we haven't even moved a fraction of a percent through this galactic year. When the dinosaurs went extinct 66 million years ago, the solar system was in a completely different part of the galaxy. We are literally in a different neighborhood of the universe than we were when humanity first learned to walk. But the motion doesn't stop at the edges of our galaxy. The Milky Way itself is not floating peacefully in the void. It is currently falling toward a massive concentration of matter known as the Virgo cluster at a velocity of roughly 600 kilometers per second. At this very moment, you are moving through the cosmos at over 1.3 million miles per hour, relative to the background radiation left over from the Big Bang. This is the fundamental architecture of your existence. You're part of a nested hierarchy of spins. The Earth rotates on its axis. The Moon orbits the Earth orbits the Sun orbits the galactic center, and the galaxy drifts through the expanding web of the universe. There is no place in the universe to stand apart from this motion, because motion is what makes existence possible. Stillness, as you experience it, is a local illusion, a brief synchronized pause in a universe that doesn't do rest. If the universe were to truly stand still, gravity would win the war in an instant. Without the outward push of motion, every gas cloud would collapse into a featureless sphere, and every star would be pulled into a single, dense point of darkness. Rotation is what prevents chaos. It is the mechanism that allows the universe to build complexity out of simplicity. Spin flattens the chaos of a collapsing cloud into the organized disks of solar systems and the elegant spirals of galaxies. This leads us to a provocative possibility. Could this constant rotation be more than just a byproduct of gravity? In the world of computer science, if you're building a massive, complex environment, you don't want to calculate every single linear path for every object forever. That is too computationally expensive. Instead, you use loops. You create systems that cycle and stay localized. From this perspective, rotation might be a simulation shortcut, the most efficient way to manage matter and entropy in a grand simulated engine. By setting everything to spin, the engine of reality can maintain the stability of matter without having to track new linear coordinates for every particle moving toward an infinite horizon. Whether we are a simulation or a natural miracle, the facts remain the same. You are currently a passenger on a multi-layered, high-speed cosmic carousel. Your blood flows in spirals, your DNA twists in an elegant double helix, and the atoms in your body possess an intrinsic spin that never winds down and never stops. You are made of the universe's motion, living inside its eternal spin. As we move forward, we are going to stop looking at spin as something that happens to matter and start looking at it as what matter is. We are going to look for that first deposit in the cosmic ledger and ask why the universe began with a twist instead of a rest. Stillness is the illusion. The dance is the truth. And right now, as you sit there, you're performing the most complex high-speed choreography ever conceived. It's time to find out who or what set the music in motion. If you were to take a highly sensitive radio telescope and point it toward the empty, silent voids of your own body, you would discover something startling. You are not silent at all. You are a living broadcast. Every single moment of your existence, you are emitting a specific, rhythmic pulse into the cosmos, a radio signal with a frequency of exactly 1,420,405,751 Hz, or 1.42 gigahertz. This isn't a signal generated by your technology or your nervous system. It is being broadcast by the intrinsic quantum spin of the hydrogen atoms that make up 75% of your physical being. Every drop of water in your cells, every strand of your DNA, and every breath of air in your lungs is screaming this universal frequency into the dark. This signal, known as the hydrogen hyperfine transition, is the most stable and consistent beacon in the history of the universe. And it exists because at the most fundamental level, rotation is not something matter does. It is what matter is. To understand why your body is a radio station, we have to look inside the architecture of the hydrogen atom, the simplest and most abundant structure in existence. Inside that atom, one electron orbits one proton. But here is where our classical intuition breaks down. Both of these particles carry a property that physicists call spin. In our everyday world, we imagine spin as a ball, turning on an axis, but in the quantum world, it is far more mysterious. This intrinsic spin is a built-in, unchangeable, angular momentum that's a fundamental feature of the particle's identity. It is as essential as its mass or its electric charge. An electron doesn't start spinning or stop spinning. It simply is a spin 1/2 particle. Imagine these two particles, the proton and the electron, as two tiny permanent magnets sitting inside the heart of the atom. Most of the time, they are locked in a comfortable embrace, where their spins are aligned in opposite directions. This is the lower energy ground state of the universe. But occasionally, through a random quantum hiccup, the electron will flip its spin to align with the proton, moving into a slightly higher energy configuration. When that electron eventually decides to flip back down to its original state, it releases that extra tiny packet of energy as a photon. That photon is the 1.42 gigahertz signal. This spin flip is the heartbeat of the cosmos. Because hydrogen is everywhere, this frequency is being broadcast from nearly every corner of the observable universe. Astronomers don't look for the shape of the galaxy using visible light. They map it by listening to this 1.42 gigahertz hum. They use it as a standard beacon to find where the invisible gas clouds are swirling and where new stars are preparing to be born. It is the universal language of rotation, a signal so consistent that if we ever wanted to communicate with an alien civilization, this is the frequency we would use, because every intelligent being in the universe is made of the same broadcasting atoms. But this brings us to a profound realization that the outlier documentaries often miss. If every particle in your body is born with this built-in rotation, then stillness was never an option for you. We are taught to think of rotation as a behavior, something a planet does because it was hit by an asteroid, or something a dancer does because they pushed off the floor. But at the quantum level, the spin of your electrons and protons is a relativistic necessity. The famous physicist Paul Dirac discovered that when you combine quantum mechanics with Einstein's special relativity, the math demands that particles have spin. The electron does not spin because something set it in motion. It spins because it is mathematically impossible for it to exist without it. In this sense, rotation is the hard coding of reality. We see the signature of this rotation in the fact that your hand doesn't pass through a solid table. This solidity is caused by the Pauli exclusion principle, a law which states that two particles with the same spin cannot occupy the same space at the same time. Your physical form, your sense of touch, and the very stability of the ground you walk on are all emergent consequences of the fact that your atoms are built from restless, spinning bits of data. This means the accounting mystery we discussed earlier, the question of where the first deposit of spin came from, has a terrifyingly deep answer. The spin didn't start with the Big Bang's turbulence or the collapse of ancient nebulae. It was present in the ledger before the books were even opened. It is a property of the quantum fields that make up the universe itself. When you look at a spinning galaxy or a rotating planet, you are seeing a large-scale magnification of the same fundamental twist that exists inside your own atoms. We aren't just living in a universe that contains spinning objects. We are living in a universe where rotation is the substance of space-time. Some theories suggest that space itself is a spin network, a discrete web of pure angular momentum where every inch of the void is constructed from these quantum spin values. If this is true, then the 1.42 gigahertz signal isn't just a byproduct of hydrogen. It is a whisper from the underlying hardware of the simulation, a reminder that the stillness of your room is just a temporary synchronization with a reality that is fundamentally, eternally turning. You are not just a passenger on a spinning planet. You're a collection of hydrogen beacons participating in a shared, ancient choreography that has been broadcast since the dawn of time. As we move into the next chapter, we will see how this microscopic rotation scales up to create the most violent and beautiful structures in the cosmos. But never forget that the most profound mystery of the universe is currently pulsing inside your own chest, at 1.42 gigahertz, waiting for you to listen. If we have learned anything so far, it is that the universe refuses to stay still. We have seen the Earth outrunning sound, the sun hurtling around the galactic core, and the atoms in your very cells broadcasting a quantum heartbeat of spin at 1.42 gigahertz. At every level we have probed, from the microscopic to the cosmic, the story is the same. Motion, rotation, and an obsessive preservation of angular momentum. But here is the part that should genuinely bother you, a statistic so staggering that it threatens to upend our entire intuition about physical reality. If you were to do a complete cosmic accounting, if you added up every spinning galaxy in the sky, every orbiting star, every rotating black hole, and every twisting cloud of gas, the total angular momentum of the entire observable universe appears to be exactly zero. Every individual piece of the cosmos is screaming in motion, frantically turning in the dark. Yet when you zoom out far enough to see the whole, the universe is perfectly, hauntingly still. This is the net zero paradox. It is the ultimate expression of what we call the accounting mystery, a universe that keeps perfect books on a quantity whose origin it completely refuses to explain. We find ourselves living inside a zero-sum game of infinite rotation, where every plus in the rotation column is matched with a minus somewhere else in the ledger. maintaining a balance so precise that it defies simple explanation. Is this just an extraordinary coincidence, or are we looking at a fundamental balancing of the books that was signed into law at the very moment of creation? To grasp the weight of this zero, we first have to understand the scale of the individual entries in the ledger. There are roughly 2 trillion galaxies in the observable universe. Each one of them is a massive, luminous whirlpool containing hundreds of billions of stars, and almost every single one of them is rotating. Some are spinning clockwise, others counterclockwise. Beneath them, stars like our Sun are turning on their axes while orbiting a supermassive black hole that is itself a vortex of light and time. Beneath that, planetary systems are spinning, moons are circling, and atoms are flipping their spins in a never-ending quantum dance. The universe is vibrating with rotational energy. Yet when radio astronomers and cosmologists point their most sensitive instruments at the deepest reaches of space, they find no evidence of a master spin. They look at the cosmic microwave background, the thermal afterglow of the Big Bang that fills the sky in every direction, and they see a near-perfect uniformity. If the universe were rotating as a whole, it would have a preferred axis. It would look different in one direction than it does in another, but it doesn't. The universe is isotropic, meaning it looks the same no matter which way you face your experiment. For every galaxy we find spinning one way, there is a statistical counterpart somewhere else spinning in the opposite direction, cancelling the total out to nothing. This leads us to the heart of the accounting mystery. In physics, the law of conservation of angular momentum is absolute. It is not a suggestion or a rule of thumb. It is a mathematically exact promise that any spinning or orbiting system will continue its motion indefinitely unless an external twisting force, a torque, acts upon it. In the vacuum of space, there is almost no friction to slow these turns down. This means that every unit of spin we see today has been preserved with perfect fidelity since the beginning of time. Every spin you can measure in an electron in your body right now is angular momentum that was present in the quantum fields of the early universe. If the total angular momentum today is zero, it means that the total angular momentum at the very first moment must also have been zero. This creates a profound paradox of creation. We see the first deposit was nothing, an empty account, yet the ledger today is filled with trillions of individual line items that all add up to that same nothingness. It is as if the universe didn't start with a push but with a split. Tidal torque theory suggests that galaxies acquired their spin not from a primordial rotation of the whole, but by tugging on each other as they formed. One galaxy gains spin, its neighbour gains an equal and opposite spin, and the total budget of the cosmos remains at zero. The universe, it seems, is a master of perfect bookkeeping, ensuring that no net motion is ever created while allowing every piece within it to frantically move. But why does the zero matter? Why couldn't the universe have started with just a little bit of global spin? The answer lies in a mathematical nightmare uncovered by Kurt Gödel in 1949. Gödel took Einstein's equations of general relativity and found a solution that described a rotating universe. In this universe, the rotation would twist the very fabric of space and time so severely that closed time-like curves would form. This is the physical realization of a time machine. In a rotating universe, you could fly in a wide enough circle and arrive back at your starting point before you even left. A rotating universe would be a place where causality is broken, where your past and your future are smeared into a single, terrifying loop. The fact that we have an arrow of time that only points forward, the fact that you can remember yesterday, but not tomorrow, is likely only possible because the universe's total rotation is zero. The zero isn't just an interesting statistic, it is the stabilizer that keeps reality from collapsing into a causal nightmare. The zero is doing all the work to keep time moving in a straight line. This brings us back to Noether's theorem, the most haunting result in all of science. Emmy Noether proved that every symmetry in nature corresponds to a conservation law. We have angular momentum conservation because the universe has rotational symmetry. The laws of physics are the same regardless of which direction you point your experiment. This symmetry guarantees that the spin will be preserved once it exists, but it says absolutely nothing about why we started with zero. Initial conditions are separate from the laws of physics. The equations of general relativity tell us how space curves and how matter moves, but they take the initial deposit as an input, not an output. Science can explain how the ice skater spins faster as she pulls in her arms, but it cannot explain why the skater was on the ice to begin with, or why her total starting motion was zero. We are left looking at a fierce deposit slip that is blank, despite the trillions of transactions currently happening in the cosmic account. Some speculate that this balance is a consequence of simulation mechanics, where a net zero angular momentum is the most stable and efficient way to render a reality without the whole system drifting or crashing. Others point to inflation, a period of extraordinary expansion in the first fraction of a second that would have diluted any primordial spin until its density was effectively zero. But these are theories trying to explain a mystery that the universe itself has written in every star and every atom. In every direction we look, we find a cosmos that is restlessly turning, yet perfectly still. We find galaxies that inherited their spin from ancient clouds, stars that preserved the memory of their birth, and particles that spin as a requirement of existence. We find ourselves in a universe that keeps perfect books, where every turn of a planet and every swirl of a galaxy is a line item in a balance sheet that always adds up to nothing. The net zero paradox is the ultimate clue that we are part of something designed, or at least organized, with a precision that reaches past our best theories. You are not just standing on a spinning world, you are riding a local fluctuation in a zero-sum game of infinite rotation. Living in a moment where stillness is an illusion, and the only true absolute is the perfect silence of the whole. In 1949, Albert Einstein was turning 70, and the world was struggling to find a gift worthy of a man who had already rewritten the laws of the stars. But while the scientific community prepared medals and plaques, Einstein's closest friend at Princeton, a man named Kurt Gödel, was preparing something far more unsettling. Gödel was a mathematical ghost, a man who had already proved that some truths are simply beyond the reach of logic. And for Einstein's birthday, he decided to look at the equations of general relativity through the lens of rotation. He asked a question that seemed simple. What happens if the universe doesn't just expand but twirls? What Gödel discovered that afternoon remains one of the most terrifying solutions in the history of physics. He proved that if the universe's net rotation ever slipped even slightly from zero, if the vast, silent balance of the cosmos were to tilt, time would no longer be a straight path leading to an unknown future. It would become a circle. He found that in a rotating universe, you could travel far enough into the deep dark, follow a specific curve, and arrive back at your starting point before you even left. This is the story of Gödel's time machine, and the shocking realization that the accounting mystery we've been tracking is the only thing keeping your past from colliding with your future. To understand the nightmare Gödel handed to Einstein, you have to picture the way we normally view the universe. We think of time as a river, an arrow that points relentlessly in one direction. You remember yesterday, you experience today, and you wait for a tomorrow that hasn't happened yet. This sense of forward feels like a fundamental law of nature, but Einstein's equations of space and time are surprisingly indifferent to it. They describe a fabric that can be stretched, warped, and dented by mass, but they don't explicitly forbid time from looping back on itself. Gödel, walking the quiet paths of Princeton with Einstein, realized that rotation changes the geometry of reality in a way that linear expansion never could. He took the same equations that describe a spinning black hole dragging the fabric of space and applied them to the entire cosmos. He imagined a universe filled with matter that was uniformly distributed, but which possessed a subtle, global rotation, a master spin. In this universe, the rotation would create what physicists call a gravomagnetic-like effect on the structure of space-time. This effect would act on what scientists call light cones. Imagine every event in your life as a flash of light. The light spreads out in a cone, defining the boundary of everywhere you can go and everything you can influence. In a normal, non-rotating universe, these cones point straight up into the future. But in Gödel's rotating universe, the global spin would act like a massive invisible hand, reaching into the fabric of space and tilting those light cones. The further you travelled from the centre of this rotating universe, the more the light cones would tip. Eventually, if you travelled far enough, the rotation would tilt the cones so severely that your future would actually point back toward your past. You would be following a closed time-like curve, a path through reality that loops back to its own origin. In Gödel's universe, time travel isn't a science fiction gadget, it is a geographic reality. You wouldn't need a DeLorean or a wormhole, you would simply need a fast enough ship and a wide enough circle. This is the point where the accounting mystery, that impossible net zero we discovered in the last chapter, starts to look like a structural shield for our reality. Remember, when we add up every spinning galaxy and every orbiting star, the total angular momentum of the observable universe is zero. For a long time, we thought this was just a statistical accident, a curious result of a messy Big Bang. But Gödel's math suggests that this zero is the only thing standing between us and a causal nightmare. If the universe possessed even a tiny amount of net spin, the arrow of time would become muddied. We wouldn't have a clean, universal history where cause precedes effect. Instead, the universe would be broken at its core, a place where you could potentially prevent your own birth or encounter your own grandfather in a dark alley before your parents were ever conceived. Stephen Hawking was so disturbed by this possibility that he proposed the chronological protection conjecture, the idea that the laws of physics must somehow conspire to prevent these loops from ever forming. But what if the conspiracy is actually the spin itself? What if the universe keeps its books so perfectly balanced at zero because any other number would cause the timeline to collapse into a loop? We are living in a universe that is incredibly strict about its accounting. We've looked for a global rotation using the most sensitive tools in our arsenal, satellites like Planck that map the ancient afterglow of the Big Bang. These measurements have set a limit so tight it's almost impossible to grasp. If the universe is rotating at all, it hasn't completed even 1/1000th of a single degree of a turn in the entire 13.8 billion year history of time. For all practical purposes, the universe is standing still as a whole, while every piece within it is screaming in motion. This perfect stillness is the stabilizer of your life. It is the anchor that allows time to flow in a straight line. The reason you can trust that today will lead to a new tomorrow is that the universe's net angular momentum has remained at zero since the first deposit was made. Think about what this implies. We usually view spin as a byproduct of gravity, something that happens when a gas cloud collapses or a star is born. But Gödel's solution suggests that rotation is deeply, fundamentally linked to the flow of time itself. Spin is not just motion, it is the gear work that keeps the now from sliding back into the then. In every galaxy you see through a telescope, there is a billion-year-old dance of rotation. In every atom of your body, there is a quantum spin broadcasting its presence at 1.42 gigahertz. We are a collection of spinning parts inside a non-spinning whole. It's like a massive gyroscope that is spinning internally with infinite energy, yet whose outer frame never wobbles a millimeter. This balance is what creates the background of our lives. It is the silent, non-rotating stage that allows cause and effect to function. If that zero ever slipped, if a cosmic transaction went unrecorded and the universe developed a net twist, the very concept of a path would disappear. The universe would become a hall of mirrors, where your future self is always just around the next bend of the galactic spiral. You wouldn't just be moving through space, you would be drifting through a sea of chronological loops. Einstein, upon reading Gödel's gift, was deeply troubled. He recognized that his friend had found a crack in the logic of reality. If rotation could turn time into a circle, then our understanding of time was missing something massive. The accounting mystery we've been exploring isn't just about physics, it's about existence itself. We aren't just looking for the first deposit of spin to understand how galaxies formed. We are looking for it to understand why we are allowed to have a history at all. The universe does not do stillness, yet it maintains a global silence that protects the arrow of time. If we have learned anything from our journey through the cosmic ledger so far, it is that the universe is a master of efficient accounting. We have seen how gravity twists chaos into order, and how the sacred law of angular momentum ensures that every turn of a planet is a fossilized memory of the Big Bang. But as we stand at the threshold of the most provocative mystery of all, we have to ask a question that most textbooks are too afraid to touch. What if the reason everything in the universe spins is not because of a physical accident, but because of a computational necessity? To understand this, we have to pivot our perspective away from space as a vast empty vacuum and start looking at it as an engine, a grand simulated machine that requires optimization to function without crashing. In the world of high-level coding, if you want to build a massive, complex environment, you don't want to calculate every single linear path for every single object for all of eternity. That requires infinite memory and an impossible amount of processing power. Instead, you use loops. You create systems that repeat that cycle and that stay localized. This is the simulation shortcut. The idea that rotation is the heartbeat of a digital engine, used to manage entropy and rendering efficiency at a scale so vast we are only just beginning to see the code. Imagine you are the architect of a reality. You have billions of galaxies, trillions of stars, and an unfathomable number of subatomic particles that all need to be tracked and updated in real time. If you allow these objects to move in perfectly straight lines forever, your simulation faces a catastrophic problem. Linear motion is a computational nightmare because objects eventually leave the local rendering area, forcing the system to expand its boundaries and track new coordinates across infinite voids. But if you introduce the shortcut of rotation, the problem is solved. By curving motion into an orbit or a spin, the system can keep matter localized and stable, trapped in a repeating loop that is much cheaper to calculate. In this view, the reason that Earth orbits the Sun and the Sun orbits the galactic center isn't just a consequence of gravity. It's a way for the universe to keep its assets exactly where the engine can see them without having to render an ever-expanding horizon of empty space. This theory provides a hauntingly logical explanation for the net zero paradox we uncovered earlier. Remember the staggering statistic? Add up every spinning thing in the cosmos, and the total angular momentum is exactly zero. In any other context, this would be an impossible coincidence, but in a simulated reality, a net zero balance is a fundamental requirement for system stability. If the total rotation of the universe were anything other than zero, the entire coordinate system of the simulation would begin to drift. This drift would eventually cause the internal geometry to warp so severely that the rules of cause and effect would break down, leading to the causal loops and time machines that Kurt Gödel discovered in Einstein's equations. By keeping the universal spin at exactly zero, the simulation ensures that the arrow of time points forward with perfect, predictable precision, preventing the hardware from crashing into a recursive nightmare. But the optimization goes even deeper than galactic orbits. It reaches down into the very substance of matter itself. We are told that subatomic particles have intrinsic spin, a built-in angular momentum that never slows down and never stops. Physicists admit this isn't a literal rotation. An electron isn't a tiny ball spinning in space, yet it behaves mathematically as if it were. From a simulation perspective, this intrinsic spin is the ultimate hard-coded metadata. It is a fixed bit of data assigned to every particle to define its identity and govern its interactions without the system needing to calculate its rotational history. This spin is what creates the Pauli exclusion principle, the law that forbids two particles from occupying the same space, which is the only reason matter feels solid. Without this spin code, the simulation would have no way to prevent matter from overlapping and collapsing into a featureless, structure-free plasma. The solidity of the chair you're sitting on is effectively a collision detection script powered by the intrinsic rotation of your atoms. This perspective also changes how we look at entropy, the slow march toward disorder, and the eventual heat death of the universe. In a typical system, energy spreads out until everything is cold and still, but rotation provides a mechanism to delay this decay. A spinning system, whether it's a hurricane on Earth or a spiral galaxy in the void, creates a dynamic equilibrium, a balance that allows complexity and structure to persist far longer than they should. Rotation allows the simulation to manage its resource budget, recycling motion, and organizing matter into efficient, long-lasting patterns like the spiral arms of a galaxy. These spirals are not static structures. They are density waves, patterns of creation that move through the disk, triggering the birth of new stars as they turn. The universe doesn't just spin to stay in motion, it spins to stay alive, using rotation as a buffer against the rising noise of entropy. We even see clues of this computational logic in the way space and time react to the most extreme rotations in the cosmos. Near a spinning black hole, we observe a phenomenon called frame dragging, where the black hole's rotation actually pulls the fabric of space and time along with it. The shortcut becomes so powerful here that the distinction between motion and geometry begins to blur. In these regions, the simulation is overclocked, pushing the limits of what the underlying code can handle. The rotation becomes the space itself, creating a swirling vortex where the very rules of reality are dictated by the turn. This suggests that our traditional view that objects spin inside space might be backwards. It is more likely that space is constructed from a network of spins, and the motion we see is just the surface level of a much deeper algebraic architecture. This simulation shortcut theory bridges the gap between the mechanical and the metaphysical, offering a reason for the universal turn that goes beyond simple gravitational collapse. It suggests that the reason you feel a sense of peace when you look at the rotating stars or the cycles of the seasons is that you are sensing the fundamental rhythm of the engine that sustains you. You are not a separate observer of the dance, you are a conscious expression of the code itself, a brief moment where the simulation has become aware of its own turning. We are built from a universe that loves the spiral not because it is beautiful, but because it is the most efficient way for existence to persist in a finite reality. Stillness was never an option because stillness is a null value that the system cannot calculate. The spin is the heartbeat, the constant update of the universal frame, ensuring that the ledger remains balanced and the dance continues forever. As we peel back these layers of cosmic optimization, we find that the first deposit of spin was not a physical push, but an initial condition of the simulation's code. The universe spins because rotation is the language of existence, the only way for the system to build structure out of the void. In the next chapter, we will see how this digital heartbeat scales up to the largest structures imaginable. But for now, remember the lie of stillness. The room around you is not at rest. It is part of a high-velocity, zero-sum game of infinite rotation, and every atom in your body is a broadcast in a grand, rotating symphony that was set in motion before time had a name. We are passengers on a journey through a logic we are only just beginning to decode, carried by a spin that is not just emotion, but the very substance of our reality. Every time you see a spinning object, from a child's top to a spiral galaxy, you are seeing a piece of a ledger that always balances to zero. And that zero is the only reason you aren't living in a loop. But this raises a new, even more obscure question. If the universe is so careful to balance its books at zero to keep time moving forward, what happens at the edges of reality, where the spin is so fast that even the zero starts to fail? To find out, we have to look past the time machine of the entire universe and look at the engines of the final dance, the spinning black holes where space and time are already being dragged into a vortex from which not even the arrow of time can escape. We are born from spin, and as we will see, it is spin that will ultimately decide how our story ends. If we have learned anything from our journey through the cosmic ledger so far, it is that the universe is a master of efficient accounting. We have seen how gravity twists chaos into order, and how the sacred law of angular momentum ensures that every turn of a planet is a fossilized memory of the Big Bang. But as we stand at the threshold of the most provocative mystery of all, we have to ask a question that most textbooks are too afraid to touch. What if the reason everything in the universe spins is not because of a physical accident, but because of a computational necessity? To understand this, we have to pivot our perspective away from space as a vast, empty vacuum and start looking at it as an engine, a grand simulated machine that requires optimization to function without crashing. In the world of high-level coding, if you want to build a massive, complex environment, you don't want to calculate every single linear path for every single object for all of eternity. That requires infinite memory and an impossible amount of processing power. Instead, you use loops. You create systems that repeat that cycle and that stay localized. This is the simulation shortcut, the idea that rotation is the heartbeat of a digital engine, used to manage entropy and rendering efficiency at a scale so vast we are only just beginning to see the code. Imagine you are the architect of a reality. You have billions of galaxies, trillions of stars, and an unfathomable number of subatomic particles that all need to be tracked and updated in real time. If you allow these objects to move in perfectly straight lines forever, your simulation faces a catastrophic problem. Linear motion is a computational nightmare because objects eventually leave the local rendering area, forcing the system to expand its boundaries and track new coordinates across infinite voids. But if you introduce the shortcut of rotation, the problem is solved. By curving motion into an orbit or a spin, the system can keep matter localized and stable, trapped in a repeating loop that is much cheaper to calculate. In this view, the reason the Earth orbits the Sun and the Sun orbits the galactic center isn't just a consequence of gravity. It's a way for the universe to keep its assets exactly where the engine can see them without having to render an ever-expanding horizon of empty space. This theory provides a hauntingly logical explanation for the net zero paradox we uncovered earlier. Remember the staggering statistic: add up every spinning thing in the cosmos and the total angular momentum is exactly zero. In any other context, this would be an impossible coincidence, but in a simulated reality, a net zero balance is a fundamental requirement for system stability. If the total rotation of the universe were anything other than zero, the entire coordinate system of the simulation would begin to drift. This drift would eventually cause the internal geometry to warp so severely that the rules of cause and effect would break down, leading to the causal loops and time machines that Kurt Gödel discovered in Einstein's equations. By keeping the universal spin at exactly 0, the simulation ensures that the arrow of time points forward with perfect predictable precision, preventing the hardware from crashing into a recursive nightmare. But the optimization goes even deeper than galactic orbits. It reaches down into the very substance of matter itself. We are told that subatomic particles have intrinsic spin, a built-in angular momentum that never slows down and never stops. Physicists admit this isn't a literal rotation. An electron isn't a tiny ball spinning in space, yet it behaves mathematically as if it were. From a simulation perspective, this intrinsic spin is the ultimate hard-coded metadata. It is a fixed bit of data assigned to every particle to define its identity and govern its interactions without the system needing to calculate its rotational history. This spin is what creates the Pauli exclusion principle, the law that forbids two particles from occupying the same space, which is the only reason matter feels solid. Without this spin code, the simulation would have no way to prevent matter from overlapping and collapsing into a featureless, structure-free plasma. The solidity of the chair you're sitting on is effectively a collision detection script powered by the intrinsic rotation of your atoms. This perspective also changes how we look at entropy, the slow march toward disorder, and the eventual heat death of the universe. In a typical system, energy spreads out until everything is cold and still, but rotation provides a mechanism to delay this decay. A spinning system, whether it's a hurricane on Earth or a spiral galaxy in the void, creates a dynamic equilibrium, a balance that allows complexity and structure to persist far longer than they should. Rotation allows the simulation to manage its resource budget, recycling motion, and organizing matter into efficient, long-lasting patterns like the spiral arms of a galaxy. These spirals are not static structures. They are density waves, patterns of creation that move through the disk, triggering the birth of new stars as they turn. The universe doesn't just spin to stay in motion, it spins to stay alive, using rotation as a buffer against the rising noise of entropy. We even see clues of this computational logic in the way space and time react to the most extreme rotations in the cosmos. Near a spinning black hole, we observe a phenomenon called frame dragging, where the black hole's rotation actually pulls the fabric of space and time along with it. The shortcut becomes so powerful here that the distinction between motion and geometry begins to blur. In these regions, the simulation is overclocked, pushing the limits of what the underlying code can handle. The rotation becomes the space itself, creating a swirling vortex where the very rules of reality are dictated by the turn. This suggests that our traditional view that objects spin inside space might be backwards. It is more likely that space is constructed from a network of spins, and the motion we see is just the surface level of a much deeper algebraic architecture. This simulation shortcut theory bridges the gap between the mechanical and the metaphysical, offering a reason for the universal turn that goes beyond simple gravitational collapse. It suggests that the reason you feel a sense of peace when you look at the rotating stars or the cycles of the seasons is that you are sensing the fundamental rhythm of the engine that sustains you. You are not a separate observer of the dance. You are a conscious expression of the code itself. A brief moment where the simulation has become aware of its own turning. We are built from a universe that loves the spiral not because it's beautiful, but because it is the most efficient way for existence to persist in a finite reality. Stillness was never an option because stillness is a null value that the system cannot calculate. The spin is the heartbeat, the constant update of the universal frame, ensuring that the ledger remains balanced and the dance continues forever. As we peel back these layers of cosmic optimization, we find that the first deposit of spin was not a physical push, but an initial condition of the simulation's code. The universe spins because rotation is the language of existence, the only way for the system to build structure out of the void. In the next chapter, we will see how this digital heartbeat scales up to the largest structures imaginable. But for now, remember the lie of stillness. The room around you is not at rest. It is part of a high-velocity, zero-sum game of infinite rotation, and every atom in your body is a broadcast in a grand, rotating symphony that was set in motion before time had a name. We are passengers on a journey through a logic we are only just beginning to decode, carried by a spin that is not just emotion, but the very substance of our reality. If you look at the majestic spiral of a galaxy like our own Milky Way, you are looking at the most exquisite timepiece ever constructed. It is a wheel of 100 billion stars, each one a glowing second hand marking the passage of cosmic eras. But as we peel back the layers of this celestial choreography, we encounter a mystery that makes the accounting paradox look like simple arithmetic. We call it the galaxy clock problem, and it is the first place where our neat, mechanical laws of spin begin to shatter. For decades, astronomers assumed that galaxies behaved like solar systems, that the further you travelled from the centre, the slower the stars would orbit, just as Neptune crawls through the dark while Mercury races around the Sun. But when we actually looked at the clock, we found something impossible. The hands at the very edge are moving just as fast as the hands at the centre. These outer stars are screaming through the void at 500,000 miles per hour, moving so fast that they should be flinging themselves away into the intergalactic dark. Yet they don't. They stay locked in their seats, held by an invisible force that defies everything we can see. Today we are looking at the invisible architects of our reality, a ghost mass we call dark matter that isn't just providing extra gravity, but is actively steering the spin of everything you know. To understand why the galaxy clock is broken, we first have to understand how we expected it to work. In our solar system, gravity is a simple game of distance. The Sun contains 99% of all the mass, which means the gravitational grip is strongest at the centre. If Earth tried to move as slowly as Neptune, it would fall into the Sun. If Neptune tried to move as fast as Earth, it would fly away. Every planet has a speed limit, dictated by its distance from the centre. We naturally assumed galaxies followed the same rule. We saw a brilliant, dense bulge of stars at the centre of the Milky Way and assumed that this was where all the gravitational weight lived. We expected that as we looked toward the lonely sparse stars, at the edge of the galactic disk we would see them drifting slowly, barely hanging on to the distant light of the core. But in the 1960s and 70s, an astronomer named Vera Rubin looked at these rotation curves and found a flat line that haunted the scientific community. She measured the speed of stars in the outermost reaches of spiral galaxies and found that their velocity didn't drop. They were racing. Imagine standing on a merry-go-round where the people at the very edge are moving so fast that their arms should be torn from their sockets, yet they are sitting as calmly as if the machine were barely turning. This is the Newtonian crisis, according to every law of motion we have discussed so far, from the ice skater to the conservation of angular momentum. These galaxies should not exist. They should have torn themselves apart billions of years ago, their stars scattered like grains of sand in a windstorm. The only way to explain why the clock keeps ticking is to admit that we are only seeing a fraction of the machine. We are like children looking at a puppet show and assuming the puppets are moving themselves, never noticing the strings or the puppeteer hidden in the shadows. Physicists realized that for these outer stars to stay attached to the galaxy, there must be a massive amount of hidden weight providing extra gravitational scaffolding. This is dark matter. It doesn't emit light, it doesn't reflect light, and it doesn't interact with the atoms in your body. It is a massive, invisible halo that surrounds and permeates every galaxy, acting as a gravitational anchor that holds the spin in place. In the Milky Way, this invisible scaffolding is 5 times more massive than all the stars, planets, and gas clouds combined. We are passengers in a luminous disk that is actually floating inside a much larger, darker sphere. This dark matter doesn't just provide the weight to keep us from flying away, it provides the structure. Without this invisible architecture, the gas clouds of the early universe would never have had the gravitational traction to collapse into the rotating spirals we see today. Dark matter is the scaffolding upon which the luminous universe was built. It is the silent partner in the accounting mystery, the one that holds the majority of the universe's angular momentum in a vault we cannot open. But there is a deeper, more obscure theory buried in the law vault that takes this mystery to a provocative new level: the dark matter talk hypothesis. We've spent this journey talking about how spin is inherited and preserved, but we've struggled to find the steering wheel. This theory suggests that the dark matter halo isn't just a static weight, it is a spinning sea of mass that is actively steering the rotation of the visible galaxy. Think about the simulation shortcut we discussed in the last chapter. If you were designing a simulated universe, you would need a way to ensure that galaxies didn't just spin randomly, but organized themselves into the cosmic web. This fringe idea suggests that the dark matter halos were the first things to spin in the early universe, and their massive, invisible rotation provided the torque, the twisting force, that literally steered the visible matter into the spiral patterns we see. In this view, we aren't spinning because of a random quantum hiccup alone. We are spinning because an invisible ocean of mass is current driving our reality, forcing the atoms of our world to follow its dark, ancient lead. This turns the accounting mystery on its head. If dark matter is the primary carrier of the universe's spin, then our luminous world is just a secondary reflection of a much larger, darker dance. We see the signature of this steering in the way galaxies are aligned across millions of light years. They aren't pointing in random directions. They seem to be listening to the same invisible conductor, their spins synchronized with the filaments of the cosmic web. This is the dark matter talk at work. the invisible sea acting as the master clock that keeps every galaxy in the cluster in sync. Why does this matter to you, sitting in your still room? Because it means that the stability of your world, the very fact that the Earth hasn't been flung into the void, is a gift from a ghost. You are held in your seat not just by the gravity of the Earth you can touch, but by the gravitational scaffolding of a dark universe you will never see. The invisible architects have ensured that the galaxy clock keeps perfect time, even though the physics we thought we knew says it should have stopped long ago. We are living in a reality that is 80% invisible, being steered by a rotation we are only just beginning to decode. The spin of your world is not an accident, it is a controlled choreography. As we move forward into the next chapter, we will look at the spin networks that might be the very fabric of this invisible scaffolding, and ask if the reason we can't see the architects is because they are the very space we are standing on. But for now, remember the outer stars. They are racing through the dark, faster than they should be, held in a perfect circle by a hand you cannot feel. The universe isn't just spinning, it is being held together by a secret. If you look at the majestic spiral of a galaxy like our own Milky Way, you are looking at the most exquisite timepiece ever constructed. It is a wheel of 100 billion stars, each one a glowing second hand marking the passage of cosmic eras. But as we peel back the layers of this celestial choreography, we encounter a mystery that makes our earlier accounting problems look like simple arithmetic. We call it the galaxy clock problem, and it is the first place where our neat mechanical laws of spin begin to shatter. For decades, astronomers assumed that galaxies behaved like solar systems, that the further you travelled from the centre, the slower the stars would orbit, just as Neptune crawls through the dark while Mercury races around the Sun. But when we actually looked at the clock, we found something impossible. The hands at the very edge are moving just as fast as the hands at the centre. These outer stars are screaming through the void at hundreds of kilometres per second, moving so fast that they should be flinging themselves away into the intergalactic dark. Yet they don't. They stay locked in their seats, held by an invisible force that defies everything we can see. Today, we are looking at the invisible architects of our reality, a ghost mass we call dark matter that isn't just providing extra gravity, but may be actively steering the spin of everything you know. To understand why the galaxy clock is broken, we first have to understand how we expected it to work. In our solar system, gravity is a simple game of distance. The Sun contains nearly all the mass, which means the gravitational grip is strongest at the centre. If Earth tried to move as slowly as Neptune, it would fall into the Sun. If Neptune tried to move as fast as Earth, it would fly away. Every planet has a speed limit dictated by its distance from the centre. We naturally assumed galaxies followed the same rule. We saw a brilliant, dense bulge of stars at the centre of the Milky Way, and assumed that this was where the gravitational weight lived. We expected that as we looked toward the lonely sparse stars at the edge of the galactic disk, we would see them drifting slowly, barely hanging onto the distant light of the core. But in the 1960s and 70s, astronomers like Vera Rubin looked at these rotation curves and found a flat line that haunted the scientific community. She measured the speed of stars in the outermost reaches of spiral galaxies and found that their velocity didn't drop. They were racing. Imagine standing on a merry-go-round where the people at the very edge are moving so fast that they should be torn from their sockets, yet they are sitting as calmly as if the machine were barely turning. This is a profound violation of what the visible matter should allow. According to every law of motion we have discussed so far, from the ice skater to the conservation of angular momentum, these galaxies should not exist in their current form. They should have torn themselves apart billions of years ago, their stars scattered like grains of sand in a windstorm. The only way to explain why the clock keeps ticking is to admit that we are only seeing a fraction of the machine. We are like observers looking at a puppet show and assuming the puppets are moving themselves, never noticing the strings or the puppeteer hidden in the shadows. Physicists realized that for these outer stars to stay attached to the galaxy, there must be a massive amount of hidden weight providing an invisible scaffolding. This is dark matter. It doesn't emit light, it doesn't absorb light, and it doesn't interact electromagnetically with the atoms in your body. It is a massive, invisible halo that surrounds and permeates every galaxy, acting as a gravitational anchor that holds the spin in place. In the Milky Way, this invisible scaffolding is vastly more massive than all the stars, planets, and gas clouds combined. We are passengers in a luminous disk that is actually floating inside a much larger, darker sphere. This dark matter doesn't just provide the weight to keep us from flying away, it provides the structure. Without this invisible architecture, the gas clouds of the early universe might never have had the gravitational traction to collapse into the rotating spirals we see today. Dark matter is the scaffolding upon which the luminous universe was built. It is the silent partner in the accounting mystery, the one that holds the majority of the universe's angular momentum in a vault we cannot open. But there is a deeper, more provocative theory buried in the law of modern physics, known as the dark matter talker hypothesis. We've spent this journey talking about how spin is inherited and preserved, but we have struggled to find the steering wheel. This theory suggests that the dark matter halo isn't just a static weight. It is a spinning sea of mass that may be actively steering the rotation of the visible galaxy. Think about the simulation shortcut we discussed earlier. If you were designing a simulated universe, you would need a way to ensure that galaxies didn't just spin randomly, but organize themselves into a cosmic web. This fringe idea suggests that the dark matter halos were the first things to spin in the early universe, and their massive, invisible rotation provided the torque, the twisting force, that literally steered the visible matter into the spiral patterns we see. In this view, we aren't spinning because of a random quantum hiccup alone. We are spinning because an invisible ocean of mass is current driving our reality, forcing the atoms of our world to follow its dark, ancient lead. This turns the accounting mystery on its head. If dark matter is the primary carrier of the universe's spin, then our luminous world is just a secondary reflection of a much larger, darker dance. We see the signature of this steering in the way galaxies are aligned across millions of light years. They aren't pointing in random directions. They seem to be listening to the same invisible conductor, their spins synchronized with the filaments of the cosmic web. This is the dark matter torque at work, the invisible sea acting as the master clock that keeps every galaxy in the cluster in sync. Why does this matter to you? sitting in your seemingly still room, because it means that the stability of your world, the very fact that the earth hasn't been flung into the void, is a gift from a ghost. You are held in your seat, not just by the gravity of the earth you can touch, but by the gravitational scaffolding of a dark universe you will never see. The invisible architects have ensured that the galaxy clock keeps perfect time, even though the physics we thought we knew says it should have stopped long ago. We are living in a reality that is mostly invisible, being steered by a rotation we are only just beginning to decode. The spin of your world is not an accident, it is a controlled choreography. The outer stars are racing through the dark faster than they should be, held in a perfect circle by a hand you cannot feel. The universe isn't just spinning, it is being held together by a secret. Up until this point, we have treated the universe like a grand celestial stage, a vast, silent container where stars, planets, and galaxies are the actors performing a high-speed rotational drama. We have looked at the dancers, but we have largely ignored the floor they are dancing on. We've talked about how gravity twists gas into stars, and how galaxies inherit their spin from the turbulent chaos of the early universe, as if space itself were just a passive backdrop for all that motion. But as we peel back the final layer of this mystery, we encounter a radical inversion of reality that makes everything we've discussed so far feel like a surface-level approximation. This is the realm of loop quantum gravity, a frontier where the distinction between the stage and the actors completely dissolves. In this view, the reason everything in the universe spins is not because matter was placed into a vacuum and set moving. It is because space itself is not a vacuum at all. It is a granular network, a restless web of discrete quantum spin values, where rotation is the very raw material from which the geometry of our world is built. The stillness of the room you're sitting in right now is a lie. It is merely the macroscopic average of a deep, underlying, and restless rotating algebra. To grasp this, we have to travel far beyond the scale of atoms, past the point where the concept of smoothness ceases to have any meaning. If you were to take a single hydrogen atom and magnify it until it was the size of the entire observable universe, the fundamental pixels of space, the Planck scale, would still be smaller than a grain of dust. At this incomprehensible depth, space does not look like a fabric or a container. It looks like a graph, a collection of nodes and edges known as a spin network. In our everyday lives, we measure space in meters and kilometers, but at the bottom of reality, space is measured in spin. The nodes in this network aren't in space. They are the volume of space itself. The edges connecting them aren't lines through a void. They're the area of space, and the labels assigned to those edges are not distances but values of quantum angular momentum. This is the geometric mystery, the realization that the height, width, and depth of the world around you are emergent properties of trillions of tiny quantized rotations. When you reach out and touch a table, you aren't feeling a solid object sitting in a still room. You are interacting with a macroscopic approximation of a spin-based geometry. We usually think of spin as something matter does, but loop quantum gravity suggests that spin is what space is. This changes the accounting mystery of the first deposit entirely. We no longer have to wonder where the first bit of rotation came from, because rotation was never deposited into the universe. It was the currency used to build the universe in the first place. Imagine the universe not as an expanding balloon, but as a growing web of these spin relationships. In the earliest moments after the Big Bang, before stars or even atoms existed, this spin network was already turning. The turbulence of the early cosmos wasn't just gas moving through a void, it was the weaving of space itself. This is why rotation is ubiquitous at every scale. The spin of a galaxy is a large-scale echo of the same quantum algebra that defines the volume of a single room. It is as if the universe has a favourite shape, the spiral, because the underlying hardware of reality is built on the logic of the turn. This perspective offers a hauntingly beautiful answer to why we perceive stillness at all. Think of the surface of a deep, calm lake. To your eyes, it looks like a flat, motionless sheet of glass. But if you could zoom in on a single drop of that water, you would see a riot of motion, molecules vibrating, electrons spinning, and atoms colliding in a frantic, never-ending dance. Stillness is just what happens when you have so many rotations happening at once that they average out to zero from your perspective. Your chair feels still because the trillions of spin network links supporting it are so small and so numerous that their individual movements are invisible. We are living on the surface of a restless, rotating ocean of algebra, mistaking the average for the absolute. This connects back to the simulation shortcut we explored earlier. If reality is a calculation, then using a spin network as the foundation is the ultimate optimization. Instead of the system having to track the positions of objects in a pre-existing 3D grid, the grid itself is generated by the rotational relationships between data points. This explains the net zero paradox. The universe's total angular momentum is zero because the stage and the actors are perfectly balanced. For every clockwise link in the network, there is a counterclockwise relationship elsewhere, ensuring that the grand architecture remains stable even as its contents are in constant motion. If we accept that space is the content, then the galaxy clock problem and the mystery of dark matter take on a new light. Perhaps the invisible scaffolding holding galaxies together isn't just a separate type of matter, but a region where the spin network is more densely woven, providing extra gravitational traction without needing visible light. Even the fastest dancers in the cosmos, the spinning black holes, become easier to understand. A black hole isn't just a dense ball of matter. It is a region where the spin network has become so tightly twisted that it drags the very geometry of space and time along with it. The frame dragging we observe is the literal twisting of the network's edges. This is the ultimate secret of cosmic rotation. The universe doesn't spin because of an accident. It spins because it must. Stillness, if it truly existed, would mean the deletion of the spin network itself, the end of geometry, the end of volume, and the end of space. We are born from this rotation, held together by it, and destined to return to it. Every time you feel the rhythmic pulse of your own heart or watch the slow turning of the stars, you are witnessing the underlying hardware of reality expressing its own structure. You are not a separate observer of this dance. You are a conscious expression of the spin network becoming aware of itself. The intrinsic spin of the atoms in your body is the same spin that defines the volume of the space you inhabit. There is no gap between you and the void. There is only a continuous web of rotation that stretches from the smallest quantum fluctuation to the largest galactic supercluster. The reason everything in the universe spins is that there is nothing else for it to do. To be is to turn. As we conclude this chapter, look around your room once more. Do not see the walls as fixed boundaries or the floor as a solid base. See them as a vibrant, shimmering network of quantum rotations. Understand that the stillness you feel is a gift of synchronization, a brief and beautiful pause in a universe that has been twirling since before time had a name. We have found the first deposit slip of the cosmic ledger, and it wasn't a physical push, it was the algebraic foundation of existence itself. In the final chapters of our journey, we will look at how this rotating reality extraction energy from the void and where the last turn of the universe will finally lead. But for now, remember the truth of the spin network. Space isn't where we move. Space is the movement. And you, in every atom and every thought, are the dance. We have travelled from the microscopic pulse of a hydrogen atom to the majestic, slow-motion sweep of the Milky Way. But our journey now reaches its final crescendo, at the darkest and most violent edges of reality. To understand the ultimate destiny of motion, we have to look at the fastest dancers in the cosmic waltz, objects so extreme that the laws of physics seem to hold their breath in their presence. These are the spinning black holes, the engines of the final dance, where all the angular momentum we have tracked through history reaches its ultimate concentrated peak. You might imagine a black hole as a silent, static void, a place where everything simply stops. But the reality is the exact opposite. In the heart of a spinning black hole, stillness is not just impossible, it is physically prohibited. These monsters are born from the deaths of massive stars, many times the weight of our sun, which have burned through their fuel and lost the internal pressure that once held them up against the weight of their own existence. As the star collapses, its core is crushed in a matter of seconds from a sphere spanning millions of kilometers into a single infinitesimal point of infinite density called a singularity. But here is where the accounting mystery we've discussed becomes truly terrifying. The star does not lose its rotation as it dies. Instead, it inherits and compresses every unit of angular momentum the star once possessed, squeezing it into a region of space smaller than an atom. This conservation of motion forces the black hole to spin at rates that defy human imagination, with some rotating at nearly the speed of light. In the language of physics, we measure this with a spin parameter between 0 and 1, where 1 is the ultimate limit allowed by the universe, the speed at which the event horizon itself would move at the speed of light. We have discovered supermassive black holes in distant quasars that are nearly perfect spinners, reaching 95% of this theoretical maximum. These are not just objects rotating inside space, they are engines that have hijacked the geometry of reality itself. If you were to approach one of these high-speed dancers, you would witness a phenomenon known as frame dragging, or the lens-thirring effect. Near a spinning black hole, mass and rotation are so concentrated that they literally drag the fabric of space and time along with them. Imagine space not as an empty vacuum, but as a viscous fluid. As the black hole spins, it stirs that fluid into a swirling vortex. This creates a region called the ergosphere, a place outside the event horizon where the laws of rest are abolished. Within the ergosphere, space-time is being dragged so fast that it is physically impossible to stand still, no matter how powerful your engines might be. Even light, the fastest thing in the universe, is forced to follow the curve of the black hole's spin, spiraling around the dark center like water circling a drain. This twisting of the spin network of reality leads to a staggering possibility first proposed by physicist Roger Penrose in 1969. He realized that because the black hole is dragging space-time with it, the ergosphere actually contains a reservoir of pure rotational energy. Through a process known as the Penrose process, we could theoretically extract this energy from the void. If you were to drop an object into the ergosphere and have it split in two, sending one piece falling into the event horizon while the other escapes, the piece that returns could emerge with more energy than it started with. You would be quite literally stealing energy from the black hole's rotation using the first deposit of ancient starlight as a cosmic battery. The amount of energy locked in this rotation is almost incomprehensible. For a maximally spinning black hole, up to 29% of its total mass can be stored as rotational energy. This is likely the secret engine behind the most luminous objects in the cosmos, quasars and gamma-ray bursts, where spinning black holes launch jets of particles at nearly the speed of light across millions of light years. These jets are not just light, they are the exhaust of a universe that refuses to stop turning, regulating the growth of entire galaxies and shaping the cosmic web through the sheer power of their spin. But even these ultimate dancers cannot keep their motion forever. Over unimaginable spans of time, through a quantum process called Hawking radiation, black holes will slowly lose their mass and their spin. As they radiate into the void, their rotation will gradually slow, their event horizons will shrink, and after trillions of years, the fastest dancers will finally begin to tire. Yet until that final moment, they stand as the supreme evidence of our simulation shortcut or geometric mystery. They prove that space is not just a stage, but a dynamic, rotating participant in the laws of nature. When you look at the flickering light of a distant quasar, you are seeing a message written in the language of spin and light. You are seeing the final condensation of a process that began with the first quantum ripples of the Big Bang, passed down through collapsing gas clouds and rotating stars until it was distilled into its purest form at the edge of a black hole. The accounting mystery is solved here in the most extreme way possible. The universe does not lose its angular momentum. It simply hides it in the dark, dragging the fabric of time along with it to ensure the ledger always stays balanced. As we watch these engines of the final dance, we realize that the spin of an atom and the spin of a black hole are two versions of the same ancient song. We are passengers on a journey that ends in a vortex, born from a motion that has no cause, and moving toward a destiny where the turn is the only thing that remains. The black hole is the universe remembering, in the most violent and beautiful way, that stillness was never the plan. It is the ultimate proof that we live in a universe of circles, not straight lines, and that every rotation, including your own, is part of a dance that will continue until the last light fades from the void. Every journey through the cosmic ledger must eventually reach its final entry. We have watched as the universe converted its first mysterious deposit of motion into the grand spirals of galaxies and the frantic beats of pulsars. We have seen how rotation serves as the architect of space-time and the stabilizer of the arrow of time itself. But there is a haunting thought that inevitably arises when you look at a spinning top. Eventually, everything slows down. On Earth, we are used to friction and air resistance stealing our motion, but in the near-perfect vacuum of space, we assume the dance is eternal. The truth is far more bittersweet. As we look toward the deepest reaches of the future, we discover that even the universe has a finite budget of energy. We are heading toward a moment where the galaxy clock finally winds down, where the stars fade into embers, and where the majestic whirlpools of light drift into the dark. Yet even in the cold silence of the heat death, there is one final secret, a whisper of motion that refuses to die. This is the story of the last turn, and the realization that we were never just spectators of the dance. We are the universe briefly aware of its own turning. To understand the end of the universe, we have to start with the slow, patient slowing of the world beneath your feet. We think of the Earth's rotation as a constant 24-hour rhythm, but the universe is already beginning to collect its debt of motion. Every day the moon's gravity reaches out and tugs on our oceans, creating the tides that sweep across the globe. This movement creates a subtle friction against the seabed, a tiny braking force that is draining the Earth's rotational energy and transferring it to the moon's orbit. Because of this, our days are growing longer by about 2 milliseconds every century. It sounds like nothing, but across millions of years, it changes everything. When the dinosaurs walked the Earth, a day lasted only about 23 hours. In the deep future, billions of years from now, our planet will become tidally locked, one side forever scorched by the sun, the other lost in permanent night, a frozen witness to a rotation that has finally been spent. This local slowing is a microcosm of a much larger galactic decay. As galaxies drift through the cosmos, they do not turn in isolation. They interact, they collide, and they trade their angular momentum through gravitational slingshots. Over unimaginable spans of time, the coherent, beautiful spiral arms we see today will begin to blur. Stars will be flung into the intergalactic void, carrying their inherited spin with them, while others will sink toward the central black holes. The galaxy clock is not just a timepiece, it is a machine that is slowly running out of fuel. As stars exhaust their nuclear hydrogen and fade into white dwarfs, neutron stars, or black holes, the luminous energy that once highlighted the rotation will disappear. The universe will enter the era of the heat death, a state of perfect cold equilibrium where all energy has been spread so thin that no more work can be done, no more stars can ignite, and no more structure can form. It is easy to imagine this end state as a graveyard of absolute stillness, a motionless frozen void where the first deposit has finally been lost. But here is where our elite understanding of spin provides a final defiant insight. Even when the galaxies are gone, and the black holes have evaporated into a faint mist of radiation after trillions of years, the accounting mystery has one last card to play. While the macroscopic motion of planets and stars will have ceased, the microscopic rotation, the intrinsic quantum spin of every particle left in the void, will likely continue forever. The spin of an electron or a proton is not a behavior it does, it is a property of what it is. It does not require energy to maintain, and it cannot be stolen by friction. Even in the total darkness of the heat death, the vacuum of space will still flicker with these fluctuations, a faint echo of the universe's first movement, whispering through the silence. The spin network that forms the very geometry of space will remain, a restless, rotating algebra that ensures reality never truly reaches absolute zero. The dance doesn't end, it simply becomes the quietest rhythm imaginable. As we reach the conclusion of this cosmic accounting, the mystery of why everything spins takes on its final, most personal meaning. We began by asking why the stars turn and why the atoms pulse, looking for answers in the cold mathematics of gravity and the deep law of quantum fields. But as you sit in your room, outrunning the speed of sound and broadcasting your 1.42 gigahertz signature into the dark, you must realize that you are not a separate observer of this choreography. You are a participant. Every unit of angular momentum in your body was forged in the hearts of spinning stars and passed down through a chain of inheritance that stretches back 13.8 billion years to the first breath of creation. You are made of the universe's motion, living inside its eternal spin. The reason we find rotation so beautiful, the reason we are captivated by the turning of the seasons, the cycles of the tides, and the orbits of the planets, is that we are built from a reality that loves to turn. Life itself is a form of dynamic equilibrium, a brief, beautiful pause in the flow of entropy where motion becomes awareness. We are a way for the universe to look back at its own first deposit and wonder where it came from. We are the consciousness that emerged from the spiral to call the dance beautiful. So as you feel the quiet stillness of the night, remember the lie of the frame. You are riding a local fluctuation in a zero-sum game of infinite rotation. The universe spins because it must. It turns because stillness would mean the end of the structured complexity that allows you to exist. We are born from the turn, held together by the spin, and destined to return to a ledger that will always perfectly balance to zero. You are not just standing on a world that turns, you are the universe briefly aware of its own turning. And as the last star eventually fades and the galaxies drift into the long dark, that awareness, that memory of the dance is the only thing that will ever truly be ours. The spin will continue, silently and endlessly, as the heartbeat of existence that never truly stops. As we bring this journey through the fundamental architecture of cosmic rotation to a close, the stillness of the world around you should feel like the beautiful illusion it truly is. We have traveled from the 1.42 gigahertz quantum heartbeat pulsing inside your own atoms to the vortex of light and time at the edge of spinning black holes, uncovering a universe that refuses to be at rest. We have explored the accounting mystery, the staggering paradox of a universe where every individual part is screaming in motion, yet the whole perfectly balances to exactly zero. We've seen that this balance is more than just a statistic. It is the shield that protects our reality, anchoring the arrow of time and preventing the causal loops and time machines that Kurt Gödel found hidden in Einstein's equations. If the simulation shortcut or the geometric mystery has changed the way you look at the space around you, transforming it from an empty container into a granular network of quantum spins, then you've begun to see the code behind the curtain. Rotation is not just a behavior of matter, it is the raw material of existence itself. If you enjoyed this deep dive into the hidden rhythms of the cosmos, take a moment to like this video and subscribe to our channel for more quiet explorations of the universe's greatest secrets. Join the conversation in the comments. Do you believe the universe's perfect rotational balance is a mathematical necessity? Or is it the ultimate clue that we are living inside a perfectly optimized simulation? The dance of the cosmos has been turning since before time had a name, and every orbit, every revolution, and every heartbeat is a continuation of that first mysterious motion. You are never truly still. You are a participant in a 14 billion year choreography. You are quite literally the universe briefly aware of its own turning. Until next time, keep following the rhythm. One turn, one orbit, one story at a time.